This conference will now be recorded.
In today's session, we'll try to understand one more important service in AWS, that is VPC. So what is VPC, right? For what purpose we can create and use VPC? We'll try to understand. So the full form of VPC, is Virtual Private Cloud. Virtual Private Cloud. So it's a private network basically. It's a private network. It's a private network in which it's your own, it's our own, it's your own private network in cloud, in which you can place your AWS resources, in which you can place your AWS resources. AWS resources. Give me 1 minute, please. So virtual private cloud, it's your own private network in AWS, in which you can place your AWS resources, like compute resources, like EC2, EFS, ELB, RDS, EKS, set of other services, etc. So its own private network. It is your own private network in AWS, in which you can place your AWS resources basically. So a VPC is a private subsection of AWS that you can control, in which you place AWS resources. You have a full control. You have a full control over who has access to the AWS resources that you are placing inside your VPC, inside your network. So VPC will let you to logically isolate some section of AWS cloud where you can place your AWS resources. In VPC, basically it's your own network, it's your own private network. In VPC, we can control our networking environment, IP addresses, and subnetting, creating a subnetwork under that network, and routing, who can access the resources using route tables and gateways. You can control who has access to that resources, who can connect to that resources which are there in that network. We can control. VPC is all about networking. VPC is all about networking. It is your network in AWS, your own private network in AWS, in which you can place your AWS resources, and you can control what other networks can communicate, with the resources, the servers which are there in VPC, using VPC networking. So when we create an AWS account, a default VPC is created for you. Whenever you create any AWS account, right, in that region, a default VPC is created for you. You may have a doubt, sir, I have not created any VPC so far, but how come the servers are getting created? In which VPC, in which network the servers are getting created? We already discussed. In the default VPC, the servers are getting created. So VPC is all about networking. It's a virtual network. It's your own private virtual network in AWS cloud. Networking is very, very important, guys. Networking is very, very important. EC2 is all about compute. EC2 is all about compute. Compute is nothing but servers, right? And EBS, EFS, S3, these type of things all about storage resources, storage services, disks. So this VPC is a networking resource. VPC is a networking resource. We can create a network resources. You can create a network resources in the cloud, like network, subnetworks, routers, gateways, all those things. VPC is all about networking. First of all, what is network, right? Just to give a definition, what is network? Network, basically a computer network. A computer network is nothing but a group of computing devices, one or more computing devices like a servers, firewalls, routers are interconnected with each other over a physical medium or a wireless medium to exchange the data. It will form the network. So computer network is nothing but a group of computing devices. It's nothing but a group of computing devices like a servers. So computer network is nothing but it's a group of computer devices are interconnected with each other, so that they can communicate with each other. Whatever servers are which are there in a same network, whatever computing devices are there in a same network, they can communicate with each other. Computer networking refers, Computing networking refers a group of computing devices are interconnected with each other so that they can exchange the data between them. For any communication between computing devices, there should be a network. Right? So there are various networks, right? There are different types of networks. If you see, you have a lot of computing devices like a servers. If you have a lot of computing devices like a servers or some other computing devices like a routers, switches, firewalls, if these guys has to communicate with each other, right, there should be a network. This is one server, this is one compute instance, this is one compute instance, this is one server. Whether it's on-prem, whether it's a cloud, that doesn't matter. You have some servers like this. If one server has to communicate with other server, right, for exchanging the data, they should have some network, right? So if they are in the network, if they are in same network, this guy can communicate with this guy. Whatever application running in one server, whatever application is running in one server, that process running in one server can communicate with the process running in another server. So for exchanging the data, the connection is very important. The network is very important. If the devices are in the same network, then they can communicate with each other. If there is no connection, there is no network between these servers and this guy, is this server or is this servers or is this server will be able to communicate with other server if there is no network like this? No. So there should be a network, there should be a connectivity, then only they can exchange the data. The network is very important when you are communication or exchanging the data between one system to another system. So there are various types of networks. Right? We already know, right? There are various types of networks like PAN, personal area network, LAN, local area network, MAN, metropolitan area network, WAN, wide area network, like that. So PAN, personal area network, like within our home also you can have your own personal network, personal area network. Suppose you guys take within your home, you have a lot of computing devices like servers, printers, scanners, and nowadays every TV, smart TV is also there, right? Smart TV, smart appliances like smart refrigerator, smart AC. So are you guys able to communicate with the smart TV or smart AC, or by sitting somewhere in your home via your mobile only. Via your mobile only, you can exchange some information, right? Because there is a network between all those computing devices within your network, personal area network. Within your home also, there is a small network, right? You have some smart TV. Let's consider this is your smart TV. You have a printer, you have a scanner, maybe in your home. You have a printer or scanner in your home. You have your computer, laptop or desktop, which you use in our home, right? You have a smartphone. People use smartphones, right? So you have a lot of computing devices in your home. So every computing device will have an IP address. Every computing device will have an IP address. Even your smart TVs, right? Your smartphone or tab, whatever you use, they will have some IP address, private IP. Now there will be a network. There will be a network, right? Earlier we used to have a wired network. Earlier we used to have a wired network. Every home, like in your home, you may get a you may get a router, internet router. The moment you get a broadband connection, they will give some router to you, right? Router. This router is connected with some cable. This router is connected with some cable. This router is connected with some cable to enable the internet. Now, earlier, this router used to have a switches, or we call it as a switcher, that points. So your smart TV, your phone, basically your computer or desktop used to connect like this. And earlier your TV is have a point where you can connect this router. So kind of a wired network. Earlier we used to have a wired network. Now people nowadays is using wireless networks in the home. Right? So this router used to come with Wi-Fi, wireless wireless devices, router come Wi-Fi. Now, if you guys observe, if your smartphone is connected to your router, this router via Wi-Fi, and your smart TV is also connected with your Wi-Fi, and your smartphone is connected with this printer or scanner via router, all these devices are connected to same router, which means same network. Using smartphone, wireless router, right? Wireless router. So using smartphone, are you guys able to communicate with your printer or scanner? Suppose using smartphones, are you able to give the print to the printer? That is one communication, right? Because this is in the same network. Using smartphone, will you able to operate your smart TV, because smart TV also connected with same router, Wi-Fi router, that wireless router, and your smart TV and smartphone also connected to same router, which means same network. So this smartphone is able to communicate with your smart TV. So there is a small network in your home also, that we call it as a personal area network. If you guys observe, if this smartphone is connected with your mobile data, and your smart TV, is connected with this your home router, that Wi-Fi router, do you think using this smartphone will you able to operate or communicate anything with this smart TV? Did you guys observe any time? No, you can't communicate, because this device is in this network. This smartphone is in that mobile data network. So if the devices are in network, then only they can exchange the data, then only they can communicate. So networking plays very important role in the softwares. You have a PAN, like personal area network. So each and every device should be part of the network, so that they can communicate with each other. Otherwise, if they're in a different network, they can't communicate with each other. Like this, you have a PAN, you have a LAN, local area network. Like in your office or computers lab, your college computers lab, local area network. So if you observe, when you guys are in degree or engineering, you go to computer lab. From one computer, are you able to communicate something running in another computer because there is a LAN connected between all those computers, local area network within that lab or within that building or within your office building like that? Yes. So LAN, local area network, it is very less in the radius, like a small building, office building, or that can be a small college or school in which all your computing devices are connected with each other using local area network via cables. So that we call it as a LAN. That we call it as a LAN, like this. Some group of servers are interconnected with each other using kind of a cables, LAN. Now all the devices are in a LAN, same local area network. Is this server can communicate with this server? Let's say if one application is running in this server, let's say database process is running in this server. Is this server will be able to talk to this server because they are in the same network? There is a connection. Yes. So there is something called LAN, local area network. So the network is limited to small building like office building or college building, school building. All your computing devices are interconnected using LAN cables. There is something called WAN. Let me go first explain MAN. There is something called MAN, Metropolitan Area Network. Metropolitan Area Network. So this metropolitan area network spreads in some city. It is going to connect multiple LANs. It is going to connect multiple LANs in bigger range. So metropolitan area network, your network is spread in complete kind of some metropolitan area, some kind of a city. So you have multiple LANs. You have multiple LANs like this, local area networks like this, in different locations. You have a LAN like this. This is LAN 1, this is LAN 2, this is LAN 3. Like this, you have lot of local area networks, Like this, you have lot of local area networks. Like this, you have lot of local area networks. So this is LAN, local area network 2. This is local area network 1. This is local area network 3. Like this, you have lot of LANs. So all these LANs, that MAN, that metropolitan area network, is a group of local area networks. It's a collection of local area networks. All these LANs can be interconnected using something called router. There are routers, right? So this LAN can have some router. This local area network is connected with some networking device called router. And this router, and you have this, for this LAN there is a router, for this LAN there is a one more router. If these routers are connected again, the servers in one local area network, will it able to communicate with servers in another local area network? Now you are creating some kind of a bigger network here. So this is one local area network, server 1 in LAN 1. This is server 2, let's say server 1 in LAN 2, local area network 1. This is local area network 2. Now the routers, each LAN can have a router, and these routers are again connected with other network router. This is network 1, this is network 2, and this network router is again interconnected with this network router. So the servers in this network, will be able to communicate with servers in another network? Yes. So these routes will route the request. You need to add a routes. You need to add a routes. So based on the source range, and destination range, the destination range, if the destination range is so and so IP, route the traffic to this gateway, like that you will inform. So you can create a WAN, wide area network. That wide area, sorry, you can create a MAN, metropolitan area network. It is like a group of local area networks interconnected. Just to give an example, suppose you have lot of office branches. You have office branch in, let's take in one city like Bangalore. You have some office branch in Marthalli. You have some office branch in Whitefield. You have some office branch in maybe Hebal, like that. So each office has its own local area network. But if you all your offices has to be connected, all your office net servers has to be interconnected, right? You can create a MAN, metropolitan area network. All your office local area networks can be interconnected with other local area networks. Example, just to give an example, I can say your cable networks also, your cable TV, right? Earlier we used to have a cable networks, right? Cable operators. Is their network is spread across the city, right? They have a lot of networking devices like repeaters, hubs, and all those things are interconnected. So kind of a metropolitan area network. Metropolitan area network. And there is something called WAN again. There is something called WAN, wide area network. Wide area network. This is internet. Wide area network. It's a internet. So this wide area network connects the net devices, connect the servers, connect the computing devices across countries, across states, across countries and states. So if these routers, if these routers has a connection with internet, if these routers has a connection with internet, WAN is again, WAN is again kind of a, WAN is again kind of a collection of metropolitan area network. It can be collection of MANs. Let's say there is one more network, another WAN or another LAN like this. If this is also connected with internet, then the servers in one city, the servers in one city will be able to communicate with servers in another city if the network, this network has a route to the internet and this network also has a route to the internet. Does the servers in one network will be able to talk to the servers in another network? That is via public networks. Different cities also, yes. So there are different types of networks, but when it comes to the connections, right? When it comes to the connections, it can be a private connection or public connection. Public connection in the sense public network, private network, public network. Public network in the sense internet, via internet. Private network in the sense you can create a network between some LANs, some local area networks using dedicated network mediums, not via internet. Internet is not safe because the data will be exchanged in the internet, right? It is not safe, and there is no encryption like that if required. So if required, sometimes you can create your own private network also, or it can be a public network. So networking is very, very important. Your devices can be interconnected with each other privately, even though they are in a different locations, different buildings, different cities also. You can create a dedicated cable. You can connect the multiple networks, your own networks using dedicated cables. That is kind of a private network. Or you can go with public network like internet. So private network and public network. Is everyone clear again? What is public, what is private? Public in the sense internet. Via internet, you are enabling the connection between multiple networks is called as a public network. Not via internet. You can have your own networking devices, networking cables. If the networking is enabled between dedicated networks between you are owning via private connections, private cables, or private routers, repeaters. This we call it as a private network. Clear? First of all, what is networking? How important this networking is? In networking, you have a lot of devices, hubs, switches, routers, repeaters, right? Cables, fiber cables, which will enable the connectivity physically also. So you need lot of networking resources like hubs, switches, routers, repeaters, gateways, gateway, gateways, etc. to form the network, to create the network. So you can set up networks in your own data center also. When you guys are managing your own data center, that time also you need to create a network, right? Otherwise, will you guys able to access the, I mean to say, does your end users will be able to access your applications which is hosted in somewhere in your data center if there is no network? No. So you guys are managing your servers in your own data center also, you need to create a network. But if I am using cloud, these networking can be created, this type of networking can be created in the cloud using VPC. VPC is your own network, it is your own private network in which you can place your AWS resources like a servers, RDS, EKS, EFS, etc. And you have a full control what other networks can be connected with this network, what other networks can be connected with this network, what the servers in other networks, will they allow to connect or will they not allow to connect? You can control that complete networking environment, routing environment using VPC. Is everyone clear? What do you mean by VPC? VPC is a private cloud. It's your own private network in which you can place your AWS resources like EC2, ELB, EFS, RDS, etc. You have a full control. You have a full control on networking environment, and its subnets and routing. So routing in the sense, what other networks can be, what other networks, the servers in what other networks can connect with these servers, you can define using routing and gateways. Is everyone clear the what you mean by VPC? Networking is very, very important, guys. Whenever we created a EC2 instance also, there was a network. The system was created in some network, but we have not created any network. We have not created any VPC in our account as of now. There is a default VPC. So in that default VPC, it is created. Clear? Now VPC has some components. Let's discuss about the components of VPC. VPC has some components. Let's discuss about the components of VPC. VPC has something called subnets, and VPC has some component called IGW, route table, right? NAT gateway, NACL, peering connections. Like this, we have some components in VPC. So VPC is a network. VPC is a network. That network can be subdivided into a small network that we call it as a sub networks. VPC is one network. We can break that network into a small networks. We call that as a sub networks. So you can create n number of subnets, up to 200 subnets also you can create in one VPC. You can create up to 200 subnets also. But the subnets are primarily categorized into two types. The subnets are primarily categorized into two types. You can create 100 subnet, 50 subnet, 10 subnets. That doesn't matter. Primarily, those subnets are categorized into two things. One is public subnets, public subnets. Other category is private subnets, private subnets. So VPC is a network. It's a network. You can break that network into a sub-network, small network, sub-networks. Under that network, you can create a small network. We call it as a subnet. And you can create lot of subnets, but there are primarily two types of subnets: public subnet, private. What do you mean by private subnet? What do you mean by public subnet, right? The subnet which has a route to IGW, which has a route to IGW, that is internet basically. The subnet which has a route to the IGW in route table is called as a public subnet. Is called as a public subnet. The servers which are under public subnets, which are created under, or which are created under public subnets, has public subnet has access to internet. The servers which are under public subnet has access to internet. And from internet also, from internet we can also reach the servers in the public subnet. Whatever servers we have in a public subnet, we can also reach from internet, and the servers also can talk to the other servers in the internet. So the subnet which has a route to the IGW, that is internet, in the route table is called as a public subnet. The servers which are created under public subnet has access to the internet. It can access the servers in internet, and the server in that public subnet, from we can also reach that server. We can also reach or access that server from internet. That is called as a public subnet. Is everyone clear? Very important. You have to understand what is subnetwork, and again what is public subnet. Now server also has access to the internet. We can also reach the servers from internet. Now there is something called private subnet. So the subnet which doesn't have a route, the subnet which doesn't have a route, which doesn't have route to the IGW, in route table, which doesn't have a route to the IGW in the route table, is called as private subnet. The servers which are under private subnet, will not has access to the internet. From internet also we can't reach. From internet we can't reach or communicate the servers in the private subnet. We can't reach the servers from internet in the private subnet. So you have public subnets, you have private subnet. You can create n number of subnet, but that subnet can be either public or private. So what is the use of creating a servers in private subnet? You can't access from different networks. You can't access from internet, first of all. You can't access from internet. And also you can't access the servers which are there in a private server, private subnet from other networks also. Then what is the use, right? By creating a servers in private subnet, what we achieve? The network security. The network security. Is our servers created under private subnets are secured from the internet, from other networks, right? The other servers in a different networks can't reach this one. So any application or process running in these private servers, or any data or any process, any applications running in these private servers under private subnet, is this servers or process or any applications can be accessed from other servers which are there in a different network? No. So you are securing your servers from other networks. Network security. Network security. Most of our servers in real time, most of our servers like application servers, database servers, if you guys are using Kubernetes, if you guys are using Kubernetes, your EKS nodes, if you guys are using managed databases like RDS, the database servers, RDS will be created in a private subnet only under that network. And your application servers, if you guys are using virtualized deployment like your Tomcat servers, JBoss servers, WebLogic servers, Python, Node.js servers, will be created in a private subnet. If you guys are using containers, your Docker server, Docker Swarm servers, Kubernetes servers like EKS, those type of servers will be created in a private subnet only. So you may have a doubt, sir, if those servers are created in a private subnet, then end users are from internet. End users are from internet. Then how end users can reach the applications hosted in the private servers? How end users will reach the applications which is hosted in a private subnet, right? You already know end users will not directly access the servers which are in a private subnet. You will have a reverse proxy. You will have a load balancer or reverse proxy, we call it, right? So the load balancers, that reverse proxy instances can be in a public subnet. The reverse proxy instances can be in a public subnet. So can we reach that load balancer? I mean to say, does end users can reach the load balancer which is there in a public subnet with internet access? Yes. Then the load balancer, the reverse proxy server which is running in a public subnet but same network, same VPC, will it able to forward or redirect that request to the application servers which are there in a same VPC but a different subnet, private subnet? Yes. That is how you will use VPC. VPC is very important service in AWS. Not only AWS, if you guys are using your own cloud also, that is your networking environment. You need to create a network. Your network should have a sub networks, and there should be IGWs, kind of a internet connections, routers, like that. So you can simulate your own on-premise networking environment to the cloud using VPC. Is everyone clear? This what do you mean by public and private subnets? Now we have something called IGW. We have something called IGW. Next, what do you mean by this IGW? Full form of IGW: Internet Gateway. Internet Gateway. Internet Gateway. So it's a virtual. It's a virtual. It's a virtual router. You can consider it's a virtual router. It's a virtual router which enables internet connectivity, internet connection, which enables internet connection to your VPC, your VPC. It's a virtual router which enables internet connectivity to VPC. The way you have your home router, right? In your home also you have a router, right? Where the internet connection is enabled for your servers. So similarly, there is the IGW. It's a virtual router which enables internet connection, internet connectivity to your VPC, your network. But you may have a doubt, sir, you are attaching internet gateway. There should be only one internet gateway for one VPC, guys. Again, there should be only one internet gateway for one VPC. You may have a doubt, sir, if I am attaching internet gateway to the VPC, then all the subnets becomes public subnets like that, right? No, it is not like that. You are attaching IGW to the VPC, but there is something called route table. There is something called route table. In the route table, you are defining network routing. You are defining network routing. So whatever subnet has a route to the IGW in the route table, whatever subnets has a route to the IGW in the route table, that will become a public subnet. Whatever subnets which doesn't have a route to the IGW in the route table, then we can consider that as a private subnets. So IGW is an internet gateway. It's a virtual router which enables internet connection to your VPC. It will enable internet connection to your VPC. So there is something called route table, right? As I already told, only one IGW can be attached to a VPC at any point of time. An IGW can be detached. An IGW can be detached, cannot be detached. An IGW cannot be detached from a VPC if there are active resources in the VPC. Let's say you have some EC2 instances. Let's say you have some NAT instances. You have some RDS instances or EKS instances. Will you be able to detach IGW from the VPC if there are some active resources like a servers in VPC? No. So you can't detach a VPC while there are some active resources in the VPC. Without internet gateway, without IGW, the resources, the servers can talk to each other. Without IGW also, does the servers in that VPC will be able to talk to each other? The servers in that VPC, because same network, local, kind of a intranet, right? LAN, kind of a intranet, same network. So the servers can talk to each other even though there is no IGW. Without IGW, the servers in that VPC can talk to each other. But will they able to talk to the internet? The servers in that VPC, will it able to talk to the servers in internet? No. So without IGW, resources can talk to each other, but not to the internet. So there is something called route table. There is something called route table. Route table, route table contains a set of rules. Route table contains a set of rules. We call it as a routes. We call it as a routes that are used to determine that route table routes are used to determine where the network traffic is directed. Where should I route that traffic coming to the route table? Which network device I need to route? So route table contains set of rules, we call it as a routes, that are used to determine where the network is routed, where the network is directed. So the default VPC already has one route table, main route table. The default VPC, whatever VPC you have, right? For that VPC, there is already one route table. There you have a routes. You have a routes to the gateways. You have routes to the gateways that can be internet gateway or virtual private gateway or VPN gateway, whatever it is. In the route table, you can have a set of routes. VPC, the default VPC already has one route table. There are some routes defined already and subnets are associated in that route table. So you can have a multiple route tables in a same VPC. You can have a multiple route tables in a same VPC and you can route to the different gateways and you can associate with the different subnets in the route table. Route table contains set of rules. We call it as the routes that are used to determine where the network traffic is routed, where the network traffic is directed. Clear? The components of VPC, these important components, route table till here. What is this? What is this? I will explain later. NAT, NACL, peering connections. I will explain later. Guys, do you have an issue with my audio? Naveen is saying no voice. What about others? Are you guys able to hear me? Okay, I think Naveen has only problem. Maybe Naveen has to check from their side. Now, let's understand the default VPC architecture. So, guys, I already created, one second, guys. Okay, so I already created some VPC, but when you guys go to your account, when you guys go to your AWS account, when you guys go to your AWS account, if you go to VPC, there is one service called VPC. You go here, you type VPC, you see some result VPC. So if you go to this VPC, if you go to this VPC, you can see only one VPC. You can see only one VPC, but I already created one VPC. I already created one more VPC. That's why you can see like that. But if you see, if you go to your VPC, you can see only one VPC, and you can see that default VPC, yes, like that. So who created this VPC for us? This default VPC, yes, whatever you see, who created this VPC for us? AWS. And this VPC, every VPC will have a ID. Every VPC will have a ID. This VPC will have some subnets. Let me filter. I created some other subnets for other VPC, but let me filter with VPC ID. So let me filter with this VPC ID, that is default VPC. If you go to subnets, you can see only three subnets like this. You can see only three subnets like this. For that default VPC, you can see three subnets like this. Again, who created these subnets for that default VPC? AWS only. And you can see one IGW also. You can see one IGW. You can see one IGW for that VPC. You can see only one IGW in your account. So this IGW is attached with this VPC. So who created this IGW and attached to that VPC? AWS only. Now there is a default route table. There is a default route table, or we call it as a main route table. You can see only one route table for that VPC again. I created some route tables, that's why you can see multiple like this. You can see only one route table like this. You can see only one route table like this. Again, it's a main route table for this VPC. So here some routes are defined. Some routes are defined. IGW route, local route, peering route, direct connection route, like various other networks can be connected. Various other networks can be connected to this subnets in this VPC via route table. Okay. Now I have some subnets like this, three subnets. Let's consider for your default VPC. For your default VPC, you see three subnets like this. Now my question is, these subnets are public subnets or private subnet? You guys created a lot of EC2 instances already. You guys can tell me, is it private or public subnets? Whatever you guys created under this default VPC, whatever default VPC has a subnets, is are private subnets or public subnets? The guys who are answering it's a private subnet, I think you guys are not clear about VPC. I think you have not attended at least my session earlier. The guys who is attending, the guys who is saying it's a private subnet, right? I think you guys has not attended AWS or AWS sessions with me as part of DevOps, I think. If it is a private subnet, are you guys able to at least SSH? Forget about accessing any application. Are you guys able to SSH that EC2 instance from your laptops, your desktops, which you guys are using? If it is a private subnet, do you guys able to SSH to that EC2 instance? Forget about accessing any application like Jenkins, Tomcat, whatever it is. Are you guys able to SSH if it is a private subnet from your local laptop or desktop? No, because is your local laptop, is your local desktop is part of same network? No, right? It is not part of the same network. It is from internet, right? Your laptop is connected to the internet. It is from a different network. Your EC2 instances are in a different network. Then if it was a private subnet, do you think is your SSH connection also works from your SSH? You are making SSH request. No, you can't SSH also, because you are part of internet. You are part of internet and you are not connecting to that network via different private channels. Suppose you guys connected to maybe VPN, using VPN client and VPN server. Again, your laptop can become part of that private network. If you guys connected to the VPN servers which are there in that VPC via VPN clients, client server VPN, then you can access. But are you guys using any VPNs for SSHing? Before SSHing, are you guys connected to any VPN servers using any VPN clients? No. But still you are able to SSH, right? Without client server VPN also you are able to SSH, which means it's a public server. It's not a private server, because you can see these subnets, these subnets, there is a route table. There is a route table for that default VPC. There is a route table for that default VPC. That is main route table. In this route table, if you go to the routes, you can see something like this, right? 0.0.0 destination, any IP. If the destination range is this kind of a within your network, this is your network range. If this is the destination IP, target is local network, kind of a local router. So if this is the destination range, the systems is trying to contact any IP in this range, target is local. But if you guys are, this is the destination like 0.0.0/0, any IP other than this range, the target is IGW. So in this main route table, do I have a route to the IGW? Do I have a route to the IGW in this main route table? Here, whatever is there for default VPC? Yes, sir. And also, without explicit, associations, because there is no other route table for this VPC, there is no other route table for this VPC, and these subnets are not used in any other route table other than this main route table. These subnets are not used in other route table. So these subnets are associated without explicit association, which means this subnet has a route to the IGW. All these subnets, all these three subnets has a route to the IGW. Because of that, is the servers in that subnets are public? Are we guys able to reach those servers from internet? Is that server also able to reach to the internet? Yes. That is how default VPC is designed. That is how default VPC is designed. So is everyone clear? What is default VPC? What do you mean by subnet? What do you mean by route table? IGW? So this is how default VPC is designed. Are we going to create a servers in the default VPC in real time? Are you guys going to make your servers public like that? Application servers, database servers, whatever Kubernetes servers, Docker servers? No. This default VPC only for learning purpose. Only for learning or practicing AWS resources concept, we are going to use default VPC. So we are going to create our own VPC. We are going to create our own VPC. We call it as a custom VPC. We call that as a custom VPC. Custom VPC is nothing but your own VPC which you are going to create. So let's understand how to create a VPC. How to create a VPC. Guys, VPC is also one service from AWS, one resource from AWS. Can I create this VPC and its components like subnets, route tables, IGW? Can I do all the associations, linking, all these things via GUI, that is graphical user interface console, manually? Yes. Can I do it using CLI, AWS CLI? Yes. Can I make it using AWS API by writing some kind of a Boto script using SDK? Yes. Otherwise, can I create that using infrastructure as a code also? Your networks, your own networks with required subnets, routings, all those things, infrastructure as a code software, like a cloud formation that is cloud specific in AWS, cloud agnostic. You can use Pulumi, you can use Terraform also to create this VPC and its resources. So I am explaining manually. I am explaining manually how to create a VPC, how to create a subnets. What do you mean by route table? What do you mean by IGW? What do you mean by NAT? So I am going to create this manually while explaining all these components. Once we go for a Terraform, I will show how to create a VPC using Terraform. Okay. Now let me explain manually how to create all these things using console. Guys, if you know the resources, right? If you know the resources, writing the Terraform becomes easy. You need to just learn what is Terraform, how Terraform works, right? What is variables in Terraform, what is resources in Terraform, what is provider in Terraform, right? So using Terraform concepts, you are going to define your infrastructure resources. But without knowing what is AWS, what is provide, I mean to say what is VPC, what is EC2, that becomes difficult, right? So that's why first understand any cloud. First understand cloud. Then if you know the Terraform basics, Terraform concepts, I am going to explain Terraform with AWS provider, but that doesn't matter here. If you know what is Terraform, how Terraform works, what is variables, what is loops, what is conditions, what is resources, providers, provisioners, modules, state. If you know Terraform concepts, even though I am explaining Terraform with AWS, if you know other cloud resources like Azure, GCP, then you can easily automate the infrastructure provisioning for other cloud resources also using that respective providers. But you can create a respective resources. People may say, sir, are you going to explain Terraform with Azure? Are you going to explain Terraform with GCP? Are you going to explain Terraform with AWS? Guys, if you learn Terraform, if you know the any cloud, you already familiar with cloud, Azure cloud, GCP cloud, what is GCP, what are the resources are in GCP, what are the resources are in Azure, how to create and manage those resources manually. If you know, Terraform becomes easy. So that's why I told in the demo, I am going to use only AWS provider, but if you attend this course, if you know other AWS, other cloud resources like Azure, GCP, you can easily automate the infrastructure provisioning and management using Terraform. Okay, so learn first the respective cloud, then Terraform becomes easy. Without knowing what is Azure, what is GCP, you can't do infrastructure management using Terraform again. Now let's understand how to create a VPC. Guys, while creating a VPC, there are two things. VPC is a region specific. VPC is a region specific. while creating a VPC, VPC is a region specific. While creating a VPC, we need to give VPC range, VPC range, VPC range, that network range, how big that network, VPC range or network range in the form of CIDR, in the form of CIDR. While creating a VPC, we need to give the VPC range, that network range, that IP range, IP range for that network, IP range for the network. While creating VPC, while creating a VPC, right, we need to define the network range, the IP range, the network range, the IP range, the network range in the form of CIDR. And a VPC, it's a regional level service. VPC is a regional level service. So VPC is a regional level service. VPC spreads for VPC spreads into multiple availability zones in that region. VPC is a regional level service. That VPC, that networking spreads a bit across all the availability zones in that region. But when it comes to subnet, right? When it comes to subnet, when you are creating a subnets for that VPC, that subnet has to go and sit in only specific availability zone. But if required, can I create 3 subnets in one availability zone, another 3 subnets in another availability zone, another 3 subnets in another availability zone, like that? Maybe one public subnet, one private subnet in each availability zone, or maybe one public subnet and 2 private subnets in each availability zone, like that also? Yes. So subnet has to be in a specific availability zone, but VPC spreads across the whole region. VPC is a regional level service. While creating a VPC, we need to define the VPC range, the network range, in the form of CIDR. So what is CIDR? The full form of CIDR. What is CIDR? Classless interdomain routing. Classless interdomain routing. The full form of CIDR is classless interdomain routing. Classless interdomain routing. It's a method. It's a method for allocating. It's a method for allocating IP addresses and its routing. It's routing in private networks. In private networks. It's a method, or it's an algorithm for allocating IP addresses and its routing in a private networks. So if you take IP addresses, right, there is 32-bit IP address. We call it as IPv4. IPv4. Most of the cases we will use IPv4 only. Most of the cases we will use IPv4 only. So IPv4, it's a 32-bit IP address. It's a 32-bit IP address, right? You can see something like this. You can see something like this, right? So it's a 32-bit, 4 octets, 32 bits. In each octet, how many bits will be there? It's a 32-bit IP address. We call it as IPv4. Each each octet will have 8 bits. Each octet will have 8 bits. Each octet will have 8 bits. So it's a IPv4, 32-bit IP address. So when we are creating a VPC, you need to define that VPC range, that network range, in the form of CIDR. That can be IPv4 address or IPv6 also, but most of the cases we will go with IPv4. So IPv4 32-bit IP address. IPv4 32-bit IP address. So 32-bit. This IPv4 is 32-bit IP address. Something like this. 172.18.245, like that. So this is one IP. Each and every device will have an IP, unique IP in the network to communicate, right? So this is 32-bit IP, But how many octets, right? There are 4 octets. There are 4 octets here. There are 4 octets. So this is one octet. This is one octet. This is one octet. This is one octet. In each octet, how many bits? Since it's a 32-bit and it is categorized into 4 octets, so each octet how many bits? 8 bits. So 8 bits here, 8 bits here, and 8 bits here, and 8 bits here. Total 32-bit, 32-bit IP address. When we are creating a network, you need to give the network range, VPC range, in the form of CIDR. If you see the default VPC, whatever default VPC you have already, whatever default VPC you have already, is that VPC also has some CIDR. While they created also, they have defined that network range, the VPC range, in the form of CIDR. You can see here. Do you see this VPC CIDR like this? This is the default VPC CIDR they have given. So it's a range. It's a IP range. It's a IP range for that network. How many IPs will be there in that network? It is depends on this range only. So any IP you take, there will be a network bits, there will be a host bits. So this slash after whatever you have, right? This we call it as a CIDR block or network mask. CIDR block or network mask we call it. So out of 32 bits, you are saying 16 bits you are leaving for network and remaining bits are for host. So sometimes in the interview they'll ask, if this is my CIDR, how many IP addresses will be there? How many IPs will be available for that network? So there is a formula. There is a formula. Since it's a 32-bit, 2 power 32 minus n. What is this n? What is this n, right? How many bits you are giving for network? This after this slash whatever we have here, we call this as a CIDR block or network mask. CIDR block or network mask. So how many bits you are leaving for network? That is 16. 16 bits you are leaving for a network. These two octets are you are leaving for a network bits, and remaining are host bits. Remaining how many bits will be there for host? If I minus 32 minus 16, 2 power 16, which means how many IPs we will be getting, or how many IPs will be defined for that network. Under that network, how many IPs, how many devices can be created in that network? 65,536. So when you are creating a network, how big your network is depends on the CIDR. How big your network is depends on the CIDR. Suppose if you guys given something like this, in 32-bit you are giving 16 bits for network and remaining bits you are leaving for host. So how many devices, how many computing devices can be created in under that network? 65,536. That can be like a servers, that can be file system, EFS, that can be maybe routers, load balancers, or something like this. 65,536 IPs you will be getting for that network. So when you are creating a VPC, you need to define the VPC range, the network range, in the form of CIDR. It's a method for allocating IP addresses and its routing in a private network. So is everyone clear? What do you mean by this? So you will be getting 65,536 IPs in this range. So something like this. It will start with 1, 2. Since in each bit, in each octet, it is 8-bit. What is the starting number in each octet and what is the ending number in each octet? So it will start with the 0 till it will go 255, something like this. And again, with all these permutations and combinations, how many IPs I will be getting for that network? How many IPs will be available basically? How many IPs will be available with all these permutations and combinations? With these 16 bits you are leaving for a network, and 16 bits you are available for host. How many IPs you will get in all these permutations and combinations? You will get 65,536. So starting from 0, so it will go till 255 only, till 255. Is everyone clear? What do you mean by this CIDR? How to calculate how many host bits? I mean to say how many IPs will be available for host given CIDR? Whether you are creating manually, this VPC using a console, whether you are creating using Terraform. While creating a VPC, do I need to provide this some range like this, the network range in the form of CIDR? Yes. Whether you are creating manually using console, whether you are creating using Terraform, you need to provide the range, the network range, how big your network should be on the CIDR form you need to specify. So again, any IP you can't take as a private IP range. This private IP is only you are giving the range. If you see, this is the CIDR for this VPC. If you go to your servers, whatever servers are created under that network, whatever servers are created under that network, whatever servers are created under that network, right? If you observe the private IPs of that servers, if you see, I have already some servers, but these servers are created in a different network. But let me show that I already have some servers. This server is created in the default network only, default VPC. You can see this server is created in default VPC. If you see the IP address, is the private IP is in that range only. All these servers which are under that VPC private IPs, do you see is are under that range only, whatever range I have given? Yes, private IPs are in that range. So even though there is no internet, there is no IGW, does this server can talk to this server? This server can talk to other server which are there in the same VPC using private IPs itself? Yes, because all are part of same network, and there is a route. There is a route also. If you go to the route table, of that VPC, if you go to the route table of that VPC, if you go to the route table of that VPC, let me go to route table. We have only one route table for that VPC, that is main route table. If you see, do I have a route something like this 172.31.0.0/16? If this is the destination IP, target is local, kind of a local network, intranet. So will they able to talk to the servers using private IPs within that range? Does one server can talk to other server without internet also privately? Yes. So whatever you are giving, that is your private IP range, for that network. But again, does it mean can I give any IP ranges like this? Can I give any range like this as a private IP range? Again, no. You can't give anything like this. Like maybe you can't give maybe something like this again, right? So there is a standards again. There is something called RFC 1918 addresses. RFC 1918 addresses. RFC 1918 addresses. You need to use only RFC 1918 addresses as a private IP range. Only RFC 1918 addresses as a private IP range. There is something called RFC 1918 address. So RFC 1918 addresses is an IP addresses that is assigned by any enterprise company to a private network. RFC 1918 addresses is IP addresses that is assigned by any enterprise companies to a private network. these RFC 1918 addresses are not available, are not reachable in the internet. These RFC 1918 addresses are not available or not reachable in the internet. These are only for internal host, private networks. So they have given some range. You can take these ranges only as a private internal host IPs, internal private IP ranges. So sometimes in the interview they're asking one question. By looking at IP address, can you guys tell me whether it's a public IP or private IP? If your IP is in this range, whatever IP they are asking, whether it's a public IP or private IP, if that IPs are in these three ranges, then you can blindly say it's a private IP. You can blindly say it's a private IP. So these IPs are non-routable, non-reachable in the internet. No computer, no server in the world will have these IPs in this range, these IPs as a public IPs. No computer, no server in the world will have a public IP in this range, because these are RFC 1918 addresses. These are only for internal host, private IPs for your own networks, private networks. You have to take, when you are creating a CIDR, when you are creating your own network, that can be in a cloud like AWS or Azure or GCP, or that can be your own data center also. You are creating a network. When you guys are creating a network, you need to select the network range in the form of CIDR that has to be in these ranges only. So 10.0.0.0/10.255.255.255. In this range you can take, or in this range you can take, in this range you can take. If you see the default VPC CIDR, is it already in this range, right? Here you can see, right? 172.31.0.0/16. Is it in this? Only they have taken. Yes. If required, can I take something like this also, starting from 16, 16/16 or 17/ like this, 1 like 18 like this? Can I take till 31 in this range for a private network? Yes. Yes. Otherwise, can I take in this range also if required? 192.168.0.0/16, only this range, only 16, only 168 to 168 only here. I can take like this. If required, can I take in this range, private 10.0.0.0/16 or 1.16 or 2 up to 255, up to 255 also you can take in this one. So is everyone clear what is RFC 1918 addresses? RFC 1918 address is a IP addresses that are assigned by an enterprise organization to a internal network, private network. These IP addresses are non-routable, non-reachable in the internet. But again, instead of /16, can I take maybe /24 also if required? Very less. If I take /24, let's say I'm taking /24, then 24 bits I am leaving for a network. How many bits will be available for host? How many IPs you will get if this is your network range, VPC range? 2 power 32 minus 24, 2 power 8. So how many IPs you will get? 256 only. 256 if this is your network range. Here this value, allowed value is only between 16 to 28. Here this allowed value is only between 16 to 28. Suppose if you guys are giving 28, like this, how many IPs you will get? The allowed value is 16 to 28. If you are giving 24, you will get 256 IPs for that network. If you guys are giving 28, only 16 IPs, which means will I able to create more than 16 devices in that network, kind of a servers, more than 16 servers in that network, if this is my network range? No. So is everyone clear? What is CIDR? What is CIDR? What is RFC 1918 addresses? By looking IP, if they ask you to say whether it's a public IP or private IP, if your IP, whatever IP they are asking you to say, if that IP is falls under these ranges, you can blindly say it's a private IP. Clear? What do you mean by private IP? Are this RFC 1918 IP addresses? You can take any IPs as a RFC IPs in this range. When you are creating a private network, you can take in this range or in this range or in this range. That is recommended. These are RFC 1918 addresses, internal IPs, private IPs. When you are creating a VPC, it has to be mandatory that you need to define the CIDR. Better take the CIDR in RFC range. But can these IPs are reusable in different networks, which means can I create a n number of network with same private IP range? Because can I create with this range again one VPC, VPC1? Can I create one more VPC with this also, VPC2 like this also? Yes, because these are private IPs, right? This is different network. This is different network. Does private IPs are reusable in different private networks? Yes, sir. Yes, because this is different network. This is different network. Your private IPs, RFC 1818 addresses is reusable addresses in each different network. But the problem, if I want to connect these two networks, if this is the network range of one VPC, this is the network range of another VPC, which means this is the network range of network 1, this is the network range of network 2. Is it possible for me to connect these two networks privately? Again, is these two networks is possible to connect privately? No, because when you define the routes, right, IP conflict overlap will happen. You should not have a overlapping between your private IPs to create a private connectivities between these two networks. But if there is a network with this range, if there is a one more network like this, is it possible for me to create a private connectivity again from this network? Can I privately connect this network also, and can I define the routes if this is the range like this? Yes. But there are no chargeables. There are no charges applicable for CIDR because it is just a private IP. You are saying what is the range, private IP range for your network. There is no charges for your VPC. There is no charges for your subnets. But the moment you start creating a resources like a servers, file systems, load balancers, Kubernetes clusters, Docker servers, your NAT instances, then the moment you start accessing those servers, the charges will be applicable. If you just create a VPC, if you just have a subnets, there are no charges. Clear? What is VPC? What is CIDR with respect to VPC? What do you mean by RFC 1918 addresses? By giving IP range, if they ask you to say how many IPs you will get for that range, is everyone clear? What do you mean by this? 2 power 32 minus n. That n represents how many network bits you are giving. If you are giving 24, minus 24, these many hosts. If you are giving 16, 16, 32 minus 16. If you are giving 28, if you are giving 28, 2 power minus 32 minus 28, 4, only 16 IPs. And again, this is total IPs. This is total IPs. 2 power 32 minus n give the total IPs you are getting. Total IPs, but not all the IPs are available for your usage. Total IPs you will be getting by calculating like this. You can calculate the total IPs. But again, not all the IPs are available for our usage. AWS will reserve some IPs again. So available IPs again, available IPs again is something like this. Total IPs minus 5 into number of subnets. 5 into number of subnets. 5 into number of subnets. So in each subnet, in each subnet, first four IP addresses in that subnet range and the last IP in that subnet range again. When we are creating a subnet also, you need to define the range that should be subset of VPC range. In each subnet, first four IP addresses and last IP in that subnet is reserved by AWS. So for internal purpose, so in each subnet, right? In each subnet, the first four IP addresses and last IP address in each subnet is not available for your usage. When you create a VPC, you have to specify CIDR block for VPC. And also when you are creating a subnet, also you need to specify the subnet range in the form of CIDR. The subnet CIDR should be subset of VPC CIDR. So in each subnet, first four IP addresses and last IP address is reserved by AWS. First IP for network address, second this IP for router, VPC router. This is reserved by AWS for the DNS purpose, and this is for future usage, and this is for network broadcast. So if you guys are creating one VPC, and this is your VPC range, and under that VPC you guys are creating four subnets, then how many available IPs? This is your VPC range, total IPs is 256, but in that VPC you are creating four subnets, then how many available IPs? In each subnet 5 IPs. So is 20 IPs will be reserved by AWS only. Only 236 is available for our usage. While creating a subnet also, you need to define the subnet range in the form of CIDR. That should be subset of CIDR. So is everyone clear theoretically? What is VPC? What do you mean by CIDR while creating a VPC? And what do you mean by subnets? What do you mean by IGW, route table? So practical, I will demonstrate in the next class. Next class, I am going to create a VPC. I am going to create a subnets. I am going to create a IGW route table. I will show how to make subnets public, how to make subnets private. The lab I will continue in the next class, guys. That is Monday. Monday, I will do the VPC creation, subnet creation, IGW creation, routing, network routing using route table. Lab I will continue on Monday. Okay. Manually we will create. Later we can automate this one using Terraform. When I start Terraform, I will show that. Any questions on whatever has been discussed today? My focus is Terraform, but lot of guys don't know first of all what is Terraform, why Terraform is used for. People might be thinking Terraform is for a different purpose. Using Terraform you can provision the resources. That can be cloud resources or on-premise resources using providers. But without knowing what resources you want to provide, you can't write a Terraform script. So that's why we are discussing all these things. Try to understand all these concepts. When we go for a Terraform, we will create these resources using Terraform instead of manual. Any questions, any queries? Feel free to ask. Otherwise, I'll stop the session here. I will continue on Monday. So if you want to enroll for Terraform certification, right, you need to officially register from the Terraform website only. Terraform associate certification, you have to register here. You can see the price is $70. The price is $70 as of today. As of today, the price is $70, right? You need to enroll here. They're giving what is the charge, how much charge they're charging for that. As of today, it is $70, very less only compared to other certifications. You need to enroll in the official website. So this is the official website. So As of today, it is $70. That can vary based on their timelines also. So if you want to know more about certifications, this is the official link from HashiCorp. Thank you guys. That's it for today. Have a great weekend. I'll continue on Monday, the lab. But try to manually play around with whatever services we discussed. Try to play around with EC2 instances, security groups. Try to play around with S3. Try to play around with EBS volumes also, so that you can understand AWS also. Even though we are focusing on Terraform, you can understand AWS also. Thank you guys. I'll continue on Monday.